Okay, I know several people have asked me what I've been up to, so I wanted to give a quick update of what my recent new old hobby has been. So this is my mostly 3D printed CNC machine that I built when I was in high school. I used it to make family name signs that say like the Smith family 2020, and I sold them on Etsy. But recently I had a child now, and my wife has a ton of fun ideas for me to make new toys for him. So like any good engineer, I decided rather than just trying to resume the state of where I was, I would do a 2.0. So I completely scrapped the machine and then rebuilt it, redesigned a lot of the parts, mostly the gantry parts here. And it is now finally almost back to life, minus a few things. So I wanted to share an update with you. So this is a mostly 3D printed machine, meaning that everything, as much as it can be, is 3D printed. And then the rest is just like off-the-shelf things you could buy from like Lowe's or Home Depot, excluding the electronics. For those of you who don't know, I've been in the open source 3D printing and CNC machine space for like over 10 years. I have some other fun custom machines and contributed to open source projects for quite a while. But one of the other reasons it sparked doing the 2.0 version is that there's been a lot of advancements in like material sciences and 3D printing over the last 10 years. And so I wanted to really leverage that as well as leverage my better design skills and probably remove a lot of the unnecessary zip ties from the design, literally. So like I said, the gantry is kind of the redesigned part. So the gantry, all the black stuff, is made out of a polycarbonate carbon fiber. It's 20% carbon fiber by weight. So it's pretty cool. It looks really cool, but also it prints well and it has great mechanical properties for like, especially this use case. The rest of the parts are an ABS, which was like the original 3D printing material, and it's terrible. It's hard to print with, it smells, it's made out of styrene, toxic, but it's great for Legos, it's great for injection molding. That's why we got to the place we were with 3D printing. So real quick, I'll give a quick overview of how mine works, kind of my philosophy in it, and then just give you a quick rundown. So I designed it to be modular. Obviously, it can be any size. This was kind of size I chose. It's got a workspace of 30 inches by 24 inches by 4 inches. It has 2 quick connects here, one for a DC spindle for the router, and then one for a 5-watt laser. Still need to design new interfaces, modular interfaces to hold them, and then like a dust collection system for the spindles. This is the electronics boxes. So in here, or on the controller, I have e-stop, which will cut power, kill everything. This is spindle stop, spindle start, spindle speed. Then this is the mode select, laser mode select, and then laser indicators. Inside the box, we have fresh air coming in. This is cool to hot. So you have your motor controller. This is a Rambo board. Then you have your laser driver controller. You have your meanwhile, you have your DC power supplies, and then in the back there is a relay and then some fuses and mains power in. You'll see on the front I have this cute little this is a Raspberry Pi running some shop floor software that actually allows me to jog the machine from here when it's not just being cute. And one of the reasons that's important is sometimes you want to move the machine out of the way when you're changing spindles, whatnot. And then also you need to trigger auto homing before doing a print, because in a CNC machine, it's really important that you're very parallel, perpendicular from the axes. So I actually have some custom firmware running to be able to control each of the 5 motors independently. And then I use these limit switches here that come in contact with these end blocks to actually calibrate the different axes before the individual prints happen. Okay, so the other part of the redesign that I really wanted to focus on is that I wanted to try to do, to the best of my abilities, the whole design and manufacturing stack on an iPad. So that's why you see I have my iPad here. What that means is I've been playing around with doing 3D modeling on an iPad through the new Shaper 3D software. It's really slick. But I also not only want to do CAM, but also or not only do I want to do CAD, but also CAM. So CAM is the software where you actually generate the different tool paths and the motor control, the feeds and speeds. And so I found some web-based software where I can do that on my iPad. And then I have the Raspberry Pi is running a custom web controller to do the CNC control. So that allows me to run this custom-made web app on my iPad, and then I can do things like start my different jobs from here. I can just show real quickly, like I'll just like jog the machine 50 millimeters to the right, and then like I can do let's do just like y-axis homing, and it's already there, so that's not overly exciting. But I can show there's y-axis homed, and then also z-axis is controlled by this. You attach this to the spindle to make your contact, and then you can contact 0, and then you calculate your work piece offset. I think maybe the only other cool thing is that this is all built on a aluminum extrusion frame, which is I call it the engineer's tinker toy. It's really cool. It's very modular. Wire wraps, like everything can connect to it. Here, the wasteboard as well has some, if I can focus on it, the wire nuts embedded in the wasteboard, so you can actually really clamp down on your work pieces. So that's really helpful to have. Okay, that's a little update to my current new old hobby, what I've been up to recently. I don't know if I'll have any more updates, but just excited that the machine is finally back together and not in shambles. So if you want another update, let me know. I really like this. I'm looking forward to making some things on here for my son, and hopefully one day enjoying tinkering with this together. So thanks for watching.